Since the time of the ancient Greeks, people have wondered about the answer to the question, what is matter made of? For a long time, humans have believed that matter is composed of atoms, and in the previous 3 centuries we have collected much indirect evidence to support this belief. Very recently, something exciting has happened. For the first time, we can see individual atoms. Of course, we cannot see atoms with the naked eye, so we must use a special microscope called a scanning tunneling electroscope. Although we will not consider the details of this operation here, the STM uses an electron current from a tiny needle to probe the surface of a substance. The STM pictures of several substances are shown in Figure 11. Notice how the atoms are connected to one another by bridges, which, as we will see, represent the electrons that interconnect atoms. So at this point, we are fairly sure that matter consists of individual atoms. The nature of these atoms is quite complex, and the components of atoms don't behave much like the objects we see in the world of our experience. We call this world the macroscopic world, the world of cars, tables, baseballs, rocks, oceans, and so forth. One of the main jobs of a scientist is to delve into the macroscopic world and discover its parts. For example, when you view a beach from a distance, it looks like a continuous solid substance. As you get closer, you see that the beach is really made up of individual grains of sand. As we examine these grains of sand, we find that they are composed of silicon and oxygen atoms connected to each other to form intricate shapes. Figure 1.2. One of the main challenges of chemistry is to understand the connection between the macroscopic world that we experience and the microscopic world of atoms and molecules. To truly understand chemistry, we must learn to think on the atomic level. We will spend much time in this text helping you to learn to do that. One of the amazing things about our universe is that the tremendous variety of substances we find there result from only about 100 different kinds of atoms. You can think of these approximately 100 atoms as the letters of an alphabet from which all the words in the universe are made. It is the way the atoms are organized in a given substance that determines the properties of that substance. For example, water, one of the most common and important substances on Earth, is composed of 2 types of atoms, hydrogen and oxygen. 2 hydrogen atoms and one oxygen atom are bound together to form the water molecule. When an electric current passes through it, water is decomposed to hydrogen and oxygen. These chemical elements themselves exist naturally as diatomic molecules. They can represent the decomposition of water to its component elements, hydrogen and oxygen, as follows. Notice that it takes 2 molecules of water to furnish the right number of oxygen and hydrogen atoms to allow for the formation of the 2 atom molecules. This reaction explains why the battery in your car can explode if you jumpstart it improperly. When you hook up the jumper cables, current flows through the dead battery, which contains water and other things, and causes hydrogen and oxygen to form by decomposition of some of the water. A spark can cause this accumulated hydrogen and oxygen to explode, forming water again. This example illustrates 2 of the fundamental concepts of chemistry. 1. Matter is composed of various types of atoms. And 2. One substance changes to another by reorganizing the way the atoms are attached to each other. These are core ideas of chemistry, and we will have much to say about them. How do you tackle the problems that confront you in real life? Think about your trip to school. If you live in a city, traffic is undoubtedly a problem you confront daily. How do you decide the best way to drive to school? If you're new in town, you first get a map and look at the possible ways to make the trip. Then you might collect information about the advantages and disadvantages of various routes from people who know the area. Based on this information, you probably try to predict the best route. However, you can find the best route only by trying several of them and comparing the results. After a few experiments with the various possibilities, you probably will be able to select the best way. What are you doing in solving this everyday problem is applying the same process that scientists use to study nature. The first thing you did was collect relevant data, then you made a prediction, and then you tested it by trying it out. This process contains the fundamental elements of science: making observations, collecting data, suggesting a possible explanation, formulating a hypothesis, doing experiments to test the possible explanation, testing the hypothesis. Scientists call this process, the scientific method. We will discuss it in more detail in the next section. One of life's most important activities is solving problems, not plug and chug exercises, but real problems. Problems that have new facets to them that involve things you may never be confronted before. The more creative you are at solving these problems, the more effective you will be in your career and personal life. Part of the reason for learning chemistry, therefore, is to become a better problem solver. Chemists are usually excellent problem solvers because to master chemistry, you have to master the scientific approach. Chemical problems are frequently very complicated. There's usually no neat and tidy solution. Often it's difficult to know where to begin.